Functions. Function as a set of ordered pairs. Let A and B be two non-empty sets. A relation F from A to B, that is subset of A cross B, is called a function or mapping or map from A to B. If the two conditions are, for each A element of A, there exists B element of B such that ordered pair AB element of the relation F. If ordered pair AB element of F, ordered pair AC element of F implies B is equal to C. So, the relation F becomes a function when these two conditions are satisfied. This is the definition we have studied in class 11 as function as a relation. So, every function is a relation, but every relation is not a function. Now, let us define function as a mapping or correspondence. Function as a correspondence. Let A and B be two non-empty sets. Then a function F from set A to set B is a rule or method or correspondence which associates elements of set A to elements of set B such that all elements of set A are associated to elements in set B. An element of set A is associated to unique element in set B. These are the two conditions. That is, if A and B are two sets, if every element of A is mapped or having a correspondent to a unique element in B, then that mapping or correspondence is said to be a function. We have studied in class 11. That is, suppose in set A, this is set A and here in set B, every element of A is having a mapping or correspondence to a unique element in B, then that correspondence is said to be a function. If it is denoted by F, we may say that F is that function. If F is a function, suppose there is an element X here. This X is mapped or having a correspondence to a unique Y element of B. Suppose Y is here. So this X is having a unique correspondence or mapping here to Y. Then we write Y is equal to F of X. Here Y is called the image of X. And X is called the pre-image of Y. We have studied that in class 11. Now the set A. Set A is called the domain of the function F. So A is the domain. Domain of F. And B is called the codomain of F. B is called the codomain of F. Now set of all images, and the set of all images of the function F under the function F is called the range of F. So these are the things of what we have studied in class 11. Now let us go to different types of functions. Of course, we have studied some types of functions in class 11 also. Let us recollect that also. Before that, if A and B are two sets having M and N elements respectively, then the total number of functions from A to B is number of elements in B raised to number of elements in A. That is N raised to M. That's a point to be remembered. Now, let us discuss constant function. What is a constant function? If k is a fixed real number, then a function f of x given by f of x is equal to k for all x element of R is called the constant function. So it means that all real numbers are mapped to a single constant single real number k, then that function is called the constant function. The graph of the constant function is this. So this is the graph of the constant function. The graph will be parallel to x-axis. So here you can see that at a different points. So when k is equal to 4.5, it is moving. So all the lines, all the graphs are graphs of different constant functions. Let us discuss identity function now. Dear children, the function that associates each real number to itself is called the identity function and is usually denoted by capital I. So every element is mapped to itself. Then that function is called the identity function. The graph of identity function. This is the graph of identity function. The graph of identity function is equally inclined to the coordinate axis. And this equation of the identity function, the corresponding equation is this is the graph of identity function. This is actually is equal to y is equal to x. Is y is equal to x. Now let us discuss a modulus function. The function f of x is defined by f of x is equal to mod x is equal to x when x greater than or equal to 0 or equal to minus x when x less than 0 is called the modulus function. So this is the symbol to represent mod x. Now graph of modulus function. Graph of modulus function is this graph and it is a V-shaped graph. And here I have two branches. One is this and this vertex is at its origin. And this part, its equation is actually, and this equation is a y is equal to x. And this branch, the equation is a y is equal to minus x. Let us think about the domain and the range of this function, modulus function. Clearly, x takes all real numbers. So domain is here domain is equal to set of all real numbers. What about the range? Range is taking only the positive values. So f of x is taking only the positive values. So range is 0 to infinity or positive real numbers including 0. So this is modulus function. Let us discuss the next function, that is greatest integer function. The function f from R to R defined by f of x is equal to, this is the symbol to represent a greatest integer function. The greatest integer less than or equal to x is called the greatest integer function. From the graph it's clear, when the value of x is between 0 and 1. For example, suppose I am taking greatest integer function of 0.032 and that is equal to, now greatest integer function of 0.032 is the greatest integer less than or equal to 0.032. So 0.32 comes somewhere here and the greatest integer less than that number is 0. So this is equal to 0. Now greatest integer function of 1.999, and that is equal to the greatest integer less than or equal to 1.99, and that is 1 only. Is equal to 1. What is the domain of a greatest integer function? Is set of real numbers. What about the range? It is taking only integers, so the range is set. We have studied a set of integers set. We have studied everything in class 11. So it is just for a recollection only. Next is a signum function, another important function. The function f defined by f of x is equal to modulus of x by x when x not equal to 0, 0 when x is equal to 0. Otherwise, f of x is equal to 1 when x greater than 0, equal to 0 when x equal to 0, equal to minus 1 when x less than 0 is called the signum function. What will be the graph of the signum function? The graph of the signum function is this. So when x is greater than 0, it is 1. So it is 1. When x is equal to 0, we are taking the value here, 0. When x is less than 0, it is taking the minus 1. You just remember that in this case the 0 is excluded, and here also 0 is x, minus 1 is x. Sorry, 1 is excluded here, minus 1 is excluded here. So that is a signum function and its a graph. What is the domain of a signum function? Set of all the real numbers. What is the range of signum function? Here the domain is equal to R. What about the range? Range is equal to minus 1, 0, 1. It is taking the three values only, minus 1, 0, 1. That is the range of a signum function. Next is the exponential function. Exponential function. A function f from R to R defined by f of x equal to a raised to x, where a greater than 0 and a not equal to 1 is called the exponential function. So f of x is equal to a raised to x. Now there are two conditions. Why? Because a is greater than 0 means a can be between 0 and 1, and a is not equal to 1 also. So a can be between 0 and 1. Otherwise a can be greater than 1. So first condition, first case, when a is between 0 and 1, that is f of x is equal to a raised to x, where 0 less than a less than 1. So here the graph is this way. This is the graph. So f of x is equal to a raised to x, where 0 less than a less than 1. The graph is this way. So when a changes, the graph comes closer and closer to y-axis. And of course it passes through the point 0, 1. So the exponential function graph passes through the point 0, 1. When between 0 and 1. Now let us see what happens when a is greater than 1. So graph of f of x is equal to a raised to x when a is greater than 1. Let us see what is. So this is the graph. This is the graph of f of x is equal to a raised to x, the exponential function, when a is greater than 1. So here you can see that when a increases, what happens? The graph is coming closer and closer to y-axis, and of course here the graph passes through the same point 0, 1. So the exponential function graph passes through the point 0 and 1 always. So these are for the exponential functions. Now logarithmic function. If a greater than 0 and a is not equal to 1, then the function defined by f of x is equal to log x to the base a, where x is greater than 0, x is positive only, is called the logarithmic function. And this is the graph of the logarithmic function. The logarithmic function graph passes through the point 1, 0. Exponential function graph passes through the point 0, 1. We have studied everything in class 11. Another thing, it's another important one, it is important as far as the calculus is also. Calculus is concerned. Even and odd function. Don't misunderstand that it is connected with even number or odd number. It is even function and odd function. First of all, discuss even function. A function f is said to be an even function if f of minus x is equal to f of x. F of minus x is equal to f of x. Example, f of x is equal to x square. If you replace x by minus x, there is no harm. F of x will be x square only. F of minus x will be x square only. And another function is f of x is equal to cos x. F cos of minus x is cos x only. So f of x is equal to x square or f of x is equal to cos x, all are even functions. Now what will be odd function? A function f is said to be an odd function if f of minus x is equal to minus f of x. F of minus x is equal to minus f of x. Example, f of x is equal to x cube plus x. F of x is equal to sin x. When we replace in this first case, f of x equal to x cube plus x, if you replace x by minus x, you will get a minus x whole cube plus minus x, which is equal to minus of x cube plus x. Examples are examples for odd functions. So these are the things of what we have studied in class 11. Now we have to study some typical type of functions. Of course, that is in that type of functions starts in our text. Let us discuss that. Equality of functions. Before that, this is also I have to discuss equality of functions. Two functions f and g are said to be equal if and only if domain of f equal to domain of g. Two functions are said to be equal if and only if domain of f is equal to domain of g, codomain of f is equal to codomain of g, and the mapping also to be same. F of x is equal to g of x. If all the three conditions are satisfied, we can say that the two functions f and g are said to be equal functions. Are equal. Okay, so these are the things of what we have studied in class 11. Now let us discuss different types of functions which is not studied in class 11.